Hello everyone, myself Vinay Kumar M. So I am actually pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics. So if you want to learn physics, chemistry and mathematics starting from 8th standard till 12th standard, then please do subscribe to my channel. So I was actually teaching the 5th chapter of 8th standard mathematics, which is actually squares and square roots. So this is the part 2 video of that particular chapter. So in my first chapter, I was actually explaining about squares and how to find out square of a particular number and various properties which was associated with that particular squares. So in this particular video, I'll be explaining exercise 5.1 and exercise 5.2, and then I will be moving on to square roots. So please go through both the parts, and there will be third part also for this particular chapter. So go through all three parts so that you can understand this chapter 5 very neatly. Coming to the first question in this particular exercise 5.1, which is there in this particular chapter 5. So in that first question, they have given some set of questions. So in which they have given certain numbers, and they are actually asking what will be the square of that particular number will be ending with. So for example, if we take the first question in this particular first question, it is actually 81. So now when you actually square this number 81, that means when you do 81 square, the answer what you will be getting, from which number the unit place of this particular perfect square number or this particular square number will be ending with. So when you take square of 81, you will get a number, and in that number the unit place what will be there, like what will that particular number end with, which number that particular number will be ending with. That is actually you should find out. So simple technique to find that is just do the square of the ending number of this particular number. So and see what is the number you are getting. So what is 1 square? 1 square is actually equal to 1. So that means the square of 81 will be ending with number 1. So the answer for first question will be 1. Similarly, if you go to second question in this particular first question, they have given 272. Just take the square of this particular ending number. So what is the square of 2? It is 2 square. So 2 square is 4. That means the square of 272. That means if you do 272 square, you will get certain number. So this particular number will be ending with 4. So 4 is the answer for the second question. Similarly, coming to the third question in this particular first question. So any numbers when you take, you just do the square of that particular number, like the ending number, and that will be the unit place which is there in that particular square number. So for example, let's take 799. Like here, third problem is 799. So you can take the square of this particular ending number. So 799 is ending with 9. So what is 9 square? 9 square is 81. What is 81 ending with? 1. That means square of 79 will be ending with the number 1. So that is what you should actually see. Here you are actually getting two numbers, but here you should just consider the ending number, that is 1. That means square of 799. So if you do square of 799, you will get a number, and this particular number will be ending with 1. So this is the answer for third question. Similarly, if you look at fourth question, there they have given 3853. You just take the square of 3. So 3 square will be 9. So that means 3853, that is 3853 square will have some number. So that number will be ending with 9. So this 9 is the answer for fourth question. Coming to the fifth question in this particular problem, it is actually 1, 2, 3, 4. So you just take the square of 4. So 4 square is actually equal to 16. So 6 is the ending number of 4 square. So that means 1, 2, 3, 4 square, you will get certain number when you do square of 1234. So this particular square number will end with 6 because 4 square is also ending with 6. Just take the square of the ending number, and whatever number it ends for that particular ending number square, with the same number the square of that total number will also be ending. So here 1, 2, 3, 4, like 1234 is square. So 2234 square will be ending with 6 because 4 square is ending with 6. So this is how you should actually solve this first question. So there are like total 10 questions present in this particular first question, and it is very easy. So I have solved some 5 questions in it. So remaining 5 questions you can actually solve. Similarly, you can follow this method and you can actually solve and find out the square number, like what will be the ending number of a particular number's square. Coming to the second question in this particular exercise 5.1, they have given certain set of questions, means certain set of numbers in this particular second question. So you should actually give the reason why these numbers are not perfect square. They have given all these numbers are not a perfect square, and you should actually find out what is the reason for it. So before going into solving of this particular question, I will just give you a concept where 2, 3, 7, 8, if these 4 numbers are actually ending in a particular number, then that number will not be a perfect square. That means if you take any big numbers, that particular big number is ending with 2, 3, 7, 8, then that particular number will not be a perfect square. So this one concept you should remember. And if that particular number is ending with single zero or 3 zeros or 5 zeros, that means odd number of zeros are there in the ending of that particular number, then that will also be not a perfect square. Because as I mentioned in the property, in one of the property in previous video, if you take square of any number which is ending with certain number of zeros, then the square number will be having 2 times the zeros which are there in its square root. So for example, 10 is one particular number which has 1 0, then square of 10 will be having 2 zeros in it. If you take 100, then square of 100 will be having 10,000, like 4 zeros, because square of 100 is 10,000 which has 4 zeros in it. That means always perfect square numbers will end with 4 zeros, not with with even zeros, not with odd zeros. So if a number is ending with odd zeros, then that is also not perfect square, and if a number is ending with 2, 3, 7, 8, then that is also not a perfect square. Coming to the first question in this particular second question, they have actually given 1057. Here you can see this particular number is ending with 7. So since this number is ending with 7, this particular number is not a perfect square. So this you can actually explain in your own words. Like you can construct a sentence where it states that this particular number is ending with 7. So hence this particular 1057 number is not a perfect square. Similarly, coming to the second question in this particular second question, they have given 23453. So 23453, again this is ending with 3. So since this number is ending with 3, this is also not a perfect square. So this particular 1057 is also not a perfect square. Similarly, if you come to third question in this particular second question, they have given 7928. Here also you can see this particular number is ending with 8. So this is also not a perfect square. In fourth question, if you look at fourth question, they have given 2, 2, 2, 2. So 4 times 2, 6 times 2 they have given. Here also you can see it is ending with 2. So this is also not a perfect square. Coming to the fifth question, so this is very important. Like they have given 64,000. This is also not perfect square because this particular number is ending with odd zeros. So this is also not a perfect square. So in this exercise you have like 8 questions in this. So I have solved 5 questions. Remaining 3 questions also you can just solve like this. So there is nothing to solve in this particular question. You should just explain why these particular numbers are not square numbers, perfect square numbers. Coming to the third question, they have given certain numbers, like certain questions in this particular third question, and they are actually asking which particular number or which particular question square of that particular number will be odd number. So here in first question they have actually given 431, where 431 is actually an odd number. So whenever you take square of an odd number, then it will always be a odd number. So this particular square, like 431 square, will be a odd number. Similarly, if you come to second question, they have given 2826. So if you take square of an even number, then square of even number will be even. Similarly, coming to third question, here they have given 7779. So this is also an odd number. So square of this particular odd number will also be an odd number. So coming to fourth question, they have given 82004. So square of this particular even number will also be even number. So in this particular third question, third and first question, if you take square of these two numbers, then it will give odd perfect squares. So coming to the fourth question in this particular exercise, they have given a certain pattern. Based on this pattern, you should find answer for this particular question and this particular question. So here you can see 11 square is 121. So 101 square is 10201. 1001 square is 1002001. So here you can easily see there are two zeros in between 1. So whenever there is two zeros in between 1, then if you write 121, then you should put two zeros in between 1 and 2, and you should put two zeros in between 2 and 1. Here also you can see there is 1 0 in between two ones. So here they have put 1 0 in between 1 and 2 and 1 0 between 2 and 1. So here you can see there is no zeros between these two ones. So that's why there is no zeros in between 1 and 2 and 2 and 1. So similarly, by seeing this logic which is given in these three problems, you can easily get the answer for this fourth and fifth problem. So here you can see 1, 2, 3, 4 zeros are there. That means if you write 1, 2, 1, then there should be 4 zeros in between 1 and 2. So 1, 2, 3, 4, and there should be 4 zeros between 2 and 1. 1, 2, 3, 4. So 1, 0, 0, 0, 0, 2, 4 zeros, that is 0, 0, 0, 0, 1 is the answer for this 1, 0, 4 zeros 1 square. So similarly here you have 1, 6 zeros 1 square. So if you want to find answer for this particular big number, you can just follow this pattern, follow this logic and get the answer. So there will be 6 zeros between 1 and 2. So 3 plus 3, 6 zeros, and there will be 6 zeros between 2 and 1. So here I am writing 6 zeros and 1. So this is the perfect square of this particular number. Coming to the fifth question, this is also similar to fourth question only. Again here they have given some pattern, and based on seeing the logic in that particular pattern, you should actually find the answers. So if you see this first three questions, you can clearly see there are two ones here. Hence they have actually taken natural numbers starting from 1 ending till 2 and descending order of that. So here you can see 1, 2, 1 is actually taken. So here two ones are there, 1, 2. So 2 times 1 is there. So they have actually taken natural numbers starting from 1 till 2, and they have stopped at 2. And again they have took the descending order of this. So after 2 it will be 1. Here 1 0 is there in between these two ones. So that's why they are putting 0 here and 0 here. So alternatively they are putting zeros. When you look at this particular third pattern, here also they have followed the same logic. 1 is there, 1 is there, 1 is there. So 3 times 1 is there. So they have started natural numbers from 1 up to 3. So they have written 1, 2, 3 in an ascending order, and from 3 again they have written in descending order, 3, 2, 1, and they have written 0 alternatively. So if you follow the same logic, here how many ones are there? 1, 2, 3, 4 ones are there. So you should actually write 4 like natural numbers up to 4, and you should write the descending order of it. Leave some space between the numbers and go on putting zeros in between the numbers. Alternatingly you should go on putting zeros in between two numbers. So this is the square of this particular 1 0 1 0 1 0 1. So now here they have given answer, and you have to find out the square root of it. So here if you see the logic which is there in the above 4 questions, here you can see 1 2 3 4 5 4 3 2 1. That means they have taken natural number up to 5. That means 5 1 should be there. So 1 2 3 4 5 1 is there. Alternatively they have taken 0. That means you should put 0 here also, like 1 0 1 0 1 0 1 0 1 square. So this is the answer for this fifth question. So coming to the sixth question, here also they have given certain pattern, and based on using the logic behind that pattern, you should find the empty spaces here, like this one, and this one. So you should actually find out the numbers which are there in that particular position. So let us try to understand the logic behind this particular pattern. You can see here 1 square plus 2 square plus 2 square is equal to 3 square. So how to look at the logic present in this particular question? So here you can clearly see when you multiply 1 and 2, what is the answer when you multiply 1 and 2? 2 is the answer. So that means the third number is the multiplication of first number and second number. That means 1 into 2 will be 2. 2 into 3 will be 6. 3 into 4 will be 12. 4 into 5 you should find out. Similarly, the result what you are getting in the RHS is actually one number greater than this particular third number. So you can see like 3 is greater than, like one number greater than 2, 7 is one number greater than 6, 13 is actually one number greater than 12. So similarly, using this logic you can find the empty spaces. So here they have given 4 square plus 5 square plus dash is equal to 21 square. So in this particular fill in the blank, you can actually fill the number. What is that? 4 into 5. So what is 4 into 5? 20. So 20 square will be there. So second logic is that the number which is there after RHS is the one number greater than this particular third number. You can easily see here 21 is there and here 20 is there. So that particular logic is also getting satisfied. Similarly, now you are getting 30 here. What number when you multiply with 5 you will get 30? 6. Only when you multiply 6 with 5 you will be getting 30. So here it should be 6 square because 5 into 6 will be 30. Similarly, 6 into 7 will be 6 sevens are 49. So here 49 square will be there. So using your second logic where the number which should be there on RHS is one number greater than the third number. So here third number is 49, one number greater than 49 is 50. So 50 square will be there on this particular fill in the blank. So this is how you should actually understand the logic behind a certain pattern, and you should complete that particular pattern. Coming to the seventh question, in that they have given 3 questions where you should actually find the sum of those particular numbers, but you should never add. You should use some other logic which is related to this squares and square root chapter without actually adding it in a usual manner. You should use some logic and you should actually tell the total result after summing up all those numbers. So coming to the first question in this particular 7th question, they have given 1 plus 3 plus 5 plus 7 plus 9. So here they have given this particular 5 numbers. You should not add this. You should actually get the answer without adding these numbers. How you can get this? You can easily see these particular numbers are actually consecutive odd numbers starting from 1. So if you go to my previous video and refer, there I have actually explained sum of consecutive odd numbers starting from 1 will actually go on giving perfect squares. So 1 plus 3 will be equal to 4. So 4 is a perfect square. Similarly, 1 plus 3 plus 5. When you add the next consecutive number to this 1 plus 3, you will get 9. So next consecutive odd number, you will get 9. So 1 plus 3 plus 5 is 9. 9 is also a perfect square. Similarly, 1 plus 3 plus 5 plus 7 is actually equal to 16, where 16 is also an odd number. That shows how many numbers, like how many consecutive odd numbers you are actually adding starting from 1. So the square of that particular number will be the sum of those particular consecutive odd numbers. Here you can see how many odd numbers are added here. 2 odd numbers are added. That means after adding these 2 consecutive odd numbers, you are getting 4, which is actually 2 square. That means this particular 2 consecutive odd numbers starting from 1 is getting added. So if you make 2 square, you will get 4. So that means when you add 1 plus 3, you are getting 4. So similarly here you can see 3 consecutive odd natural numbers starting from 1 is getting added to give 9. 9 is actually 3 square. That means square root of this particular 9 is 3, and here also you can see 3 odd numbers are added together starting from 1. So here also starting from 1, 4 odd numbers are getting added. So 1, 2, 3, 4. So 4 square will be 16. That means this particular 16 is the sum of these 4 odd numbers. So using this particular logic, you can easily find the answer for this. So how many consecutive odd natural numbers are added here? You can see 5 consecutive odd natural numbers are added starting from 1. So always you should remember it should start from 1, and immediate consecutive odd natural numbers should be go on adding. That means here you should count how many consecutive odd natural numbers are added starting from 1, and that many number you should actually square it. You will get the answer for the sum of those particular odd numbers. So here 5 odd natural numbers are getting added together. So what is the square of 5? So 5 square is 25. So the answer for this will be 5 square. That is actually 25. Similarly, coming to the second question in this particular 7th question, they have given 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19. They have added till 19. Now, if you go on adding individually all these numbers, it will take time. So you can just count how many consecutive odd natural numbers are added starting from 1. You can just go on counting it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means sum of all these 10 consecutive odd natural numbers starting from 1 will be 10 square. That is actually 100. Similarly, coming to the third question in this particular 7th question, they have given sum of consecutive odd natural numbers starting from 1 ending till 23. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19 plus 21 plus 23. So here you can go on counting how many odd natural numbers, consecutive odd natural numbers are there starting from 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer for sum of these 12 consecutive odd natural numbers starting from 1 will be 12 square. So 12 square is 144. So 144 is the answer for the sum of these particular odd natural numbers. So without adding them, using this particular logic of perfect squares, you can actually tell the answer for this particular 7th question. So coming to the 8th question, it is actually the reverse of 7th question. They have just told to express 49 as sum of odd numbers, like sum of consecutive odd natural numbers. So just in the previous question, sum of odd natural numbers starting, like consecutive odd natural numbers starting from 1 gave you a perfect square. So similarly, now they have given one perfect square which you should actually express as a sum of odd natural, like sum of consecutive odd natural numbers starting from 1. So what is the square root of 49? 7. So 7 square is actually equal to 49. That means 7 odd natural numbers starting from 1 you should actually add together. That means this 49 can be expressed as 1 plus 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. So up to 13 you can add. That means 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 will give you 49, which is actually 7 square. Here you can count how many odd natural numbers are there starting from 1. 1, 2, 3, 4, 5, 6, 7. So 7 square will be 49. So you are writing the reverse of what you did in 7th question. Coming to the second question in this particular 8th question, they have actually given 121. So this 121 is also a perfect square. So square root of 121 is 11. So 11 square will be equal to 121. And this you can actually express as sum of odd natural numbers starting from 1 till the 11th odd number starting from 1. So 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19 plus 21. So this is the sum of 11 odd natural numbers starting from 1 will give you 121. So coming to the ninth question, you should actually find how many numbers will be lying in between the squares of a particular consecutive natural numbers. So here coming to the first question, they have given 12 and 13. So 12 and 13 are two consecutive natural numbers, where if you take square of this, you will get certain numbers. So how many numbers will be there in between that? That means between 13 square and 12 square, how many numbers will be lying. So if you refer my previous video, I have explained one property. Here you should actually take the lower number as n, and the numbers which are there between this lower number square and the higher number square, that will be equal to 2n numbers. So this 2n thing you should actually remember. So if you want explanation for this, then please refer my previous video for this, which is the part 1 video of this particular chapter. So now here n is actually equal to 12. So when you multiply that n with 2, it will be 2 into 12. So 2 into 12 is 24. That means if you take square of 12 and 13, then 24 number will be there in between those two perfect square number. So if you take 13 square, it will be 169. If you take 12 square, it will be 144. So 169, between 169 and 144, there will be 24 numbers. Or between 13 square and 12 square, there will be 24 numbers. Similarly, coming to the second question in this particular ninth question, they have given 25 and 26. So among these consecutive natural numbers, 25 is lesser. So that will be equal to n. Only you should take consecutive natural numbers. You cannot take 25 and 27. Only 25 and 26. This formula will be applied only for consecutive natural numbers. So here n is equal to 25 and n plus 1 is 26. No need to worry about n plus 1. You just take what is the value for n and multiply that with 2. So 2n will be 25 into 2, that is actually equal to 50. So 50 numbers will be there in between 26 square and 25 square. So in between 26 square and 25 square, 50 numbers will be there. Coming to the third question in this particular ninth question, they have actually given 99 and 100. So here you can clearly see 99 is smaller compared to these two numbers. So 99 is actually equal to n. If you take 2n of this, so it will be 99 into 2. So what is 99 into 2? 9 2s are 18, 1 carry, 9 2s are 18, 18 plus 1 is 19. So 198 will be the answer. So 198 numbers will be there in between 99 square and 100 square. So if you take 99 square and 100 square, there will be 198 numbers present in between those two perfect square numbers. Coming to exercise 5.2, in that if we see the first question, they have given certain questions in this particular first question. So you should actually find the squares of those particular numbers which is given in this particular first question. So coming to the first question in this particular first question, that is 32. So you should actually find the square of 32. So the easiest method of finding 32 square is to split that 30 into the nearest tens place plus 1, like plus whatever it is there. So 30 plus 2 will be 32. So 32 square can be written as 30 plus 2 whole square. You might be knowing the formula a plus b whole square, which is actually equal to a square plus b square plus 2ab. So here a is 30 and b is 2. So 30 square plus 2 square plus 2 into 30 into 2. So 2 into 30 into 2, that is actually 2ab. So what is 30 square? 3 3s are 9 followed by 2 zeros, 2 2s are 4. 2 into 30 is 60, 60 into 2 is 120. So this I have actually explained by giving few examples in my previous video. So if you want to find square of any number, then you can just split like this and you can actually continue with the calculation. So it will be easy for you. So when you do 900 plus 120, it will be 1020. So plus 4 will be 1024. So when you do 32 square, you will get 1024. Coming to the third question in this particular first question, they have given 86. So if you take 86 square, then you just split this 86 into 80 plus 6. That is actually 80 plus 6 whole square. So now you can easily take a plus b whole square formula and substitute here. So 80 square plus 6 square plus 2ab. So 2ab is 2 into 80 into 6. So what is 80 square? 8 8s are 64 followed by 2 zeros because 1 0 is there in this particular 80. So 6 6 are 36. 2 into 80 is 160, or you can take 8 6 are 48. So 48 480 into 2 will be 960. So when you add this particular number, it will be like 6400 plus 960 will be 6360. So 7360. So 7360 plus 36 will be 7396. So when you take square of 86, it will be equal to 7396. Coming to the sixth question in this particular first question, they have given 46. So 46 square will be equal to 40 plus 6 whole square. So you can easily find out the answer for this by taking a plus b whole square formula. So 40 square plus 6 square plus 2 into 40 into 6. So what is 40 square? It is actually 4 4s are 16 and followed by 2 zeros, 6 6 are 36. So 40 into 2 is 80, or you can take 6 4s are 24, which is 240 into 2 will be 480. So when you actually add these three numbers, you will get the answer for 46 square. So 1600 plus 480 is 2080 plus 36 will be 2116. So 2116 is the answer for 46 square. Coming to the second question in this particular exercise, they have given certain numbers in this. Based on that particular number is one of the Pythagorean triplet. So you should find other two numbers, because in Pythagorean triplets 3 numbers will be there. So if you refer my previous video, I have given general formula for Pythagorean triplets. So 2m m square minus 1 and m square plus 1 will account for Pythagorean triplets, where m is actually greater than 1 and m is actually natural number. So based on these two conditions, if you take, then 2m m square minus 1 and m square plus 1 will be the Pythagorean triplets. Now coming to the first question in this particular second question, they have given 6. So you should substitute 6 for all these 3 and verify which particular place this particular 6 will be fitting, because here you have 2m m square minus 1 and m square plus 1. 3 terms are there. So out of those 3 terms, 6 is one term. You don't know which term that particular 6 will be belonging to. So you should just verify with everything. So let me take m square plus 1 is equal to 6. So if you take m square plus 1 is equal to 6, then m square is equal to 6 minus 1, which is equal to 5. So m will be equal to square root of 5. That means here you are getting plus or minus square root of 5. That is actually not an integer, because 5 is not a perfect square. That means this particular 6 will not belong to this m square plus 1 place. So now let us take the second term, that is m square minus 1. Here also m square minus 1, if you take it as 6, then m square minus 1 will be equal to 6, where m square is equal to 6 plus 1, that is actually equal to 7. That means here 7 is also not a perfect square. So if you take square root of this 7, you will get some decimals, because m square is 7. So m will be equal to square root of 7. That will be in decimal place. That means here you are getting answer in fraction or in decimals. That means here 6 is not equal to m square minus 1. So now the only probability left is that you can take this 6 as 2m. So if 6 is equal to 2m, then what is m? M is actually equal to 6 by 2, which is actually equal to 3. So you are getting a natural number here. So m, you are getting natural number, because here I told m should be natural number. Here you are getting some decimals and fractions. So that's why this particular 6 cannot be m square plus 1. This particular 6 cannot be m square minus 1. But this particular 6 can be 2m, because m is equal to 3. So here by using this 3, you can find the next particular Pythagorean triplets which is there along with 6. So what is the second Pythagorean triplet? It is actually m square minus 1, which is equal to 3 square minus 1, because we have found out the value for m. So 3 square minus 1 is actually equal to 9 minus 1, that is actually 8. So the next Pythagorean triplet will be m square plus 1, which will be 3 square plus 1. So 3 square plus 1 is 9 plus 1, that is actually equal to 10. So 6, 8 and 10 are Pythagorean triplets where m will be equal to 3. So the Pythagorean triplets for this first question will be 6, 8 and 10. Similarly, if I take second problem in this particular second question, they have given 14. Here also you can go on verifying which particular number. So here they are saying 14 is also a Pythagorean triplet. You should find out other two numbers along with this 14. So you just go on substituting the number 14 in this particular three numbers. So let us take 2m only in the start. So 2m is actually equal to 14. So m is actually equal to 7. So here you are getting a natural number which is greater than 1. So this condition is satisfied. So you have got m as your answer, like m is equal to 7 as your answer. Now you can easily find out m square minus 1 is actually equal to 7 square minus 1. M square plus 1 is actually equal to 7 square plus 1. What is 7 square minus 1? 7 square minus 1 is 49 minus 1. So that is 48. 7 square plus 1 is 49 plus 1, that is 50. So 14, 48 and 50 will be the Pythagorean triplets, and 14 is one number in this particular Pythagorean triplets. So 48 and 50 are the other two numbers in this particular Pythagorean triplets. Similarly, they have given 16 in third question and they have given 18 in fourth question. Similarly, how I solved the previous two problems, like that only you can solve these two problems as well, where here you should take 2m is equal to 16 and 2m is equal to 18, and you should find the value of m. So here m will be 8 and here m will be 9. So like that you should actually calculate Pythagorean triplets. Next you should substitute m in m square plus 1 and m square minus 1. So you'll get Pythagorean triplets, and here also you'll get Pythagorean triplets. Similarly, you can solve this third and fourth question. So till now I was actually teaching the part 2 video of this particular squares and square roots. So after this I will be uploading part 3 video of this particular chapter, which will be containing explanation related to square roots, and also there will be solution for exercise 5.3 and 5.4. So that will be there in part 3 video. So this is part 2 video, and similarly there is part 1 video for this chapter. So go through all 3 parts of this particular chapter so that you can clearly understand squares and square roots. So like this I will be uploading more and more videos related to physics, chemistry and mathematics. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. Thank you.